VMware, and worked, been working in Seaside and generic things. You start working in Seaside and you work at Gemstone, and what happens is you do a lot of porting of code from Squeak and Pharaoh, all right? And you run into a lot of issues. And so along the way, started doing Metacello because Monticello that was used by Squeak and Pharaoh and Gemstone, wasn't enough. And Metacello was the first step along that. And now, this is 2009 is when I started Metacello, and now we're in 2012. And I think last January I was talking to I was actually talking on the internet, on the web, to a mailing list, and someone had mentioned the perennial, well, why don't you guys use Git, all right? This is the thing that comes up every 6 months on a mailing list. How come Smalltalkers don't use Git? How come they don't do file-based Smalltalk? I just love to use VI and well, that came up again. I said, well, I'll have a race, okay? I'll do Metacello, all right? And take Metacello and basically do a Git-like, capabilities in Metacello. You take Git, and we'll have a race. And whoever wins, we all win, all right? Because we get a quick solution to the problem. 3 days after I made that statement, or maybe less, Otto Berens came on the mailing list and said, we've been doing something like this for like 3 months now, all right? So, practical Git for Smalltalk, all right? And yes, I'm going to talk about version control for Smalltalk. I'm going to talk about using file-based version control for Smalltalk. And I'm going to talk about doing version control for all of the Smalltalks using file-based. So I'm wandering into territory where angels fear trouble, all right? But we'll have to live. So let's get started right with what I learned and what I know from a month and a half, all right? End of January 29th, I started a project. It is practical to use Git, all right? It's kind of embarrassing how easy it is to do, all right? We've gone for years thinking, no, we can't do that. Well, it is practical. And acknowledge the fact it is impractical, all right, for everybody to wholesale switch, okay? And so when I'm not saying, oh, this is it. This is the end. All we have to do is all go together and we're all happy. No, right? There's many reasons for that. Many reasons for that. But this is the part that's a real bugaboo for me, is using Git for sharing code across dialects. I think that's the spot. That's a sweet spot. Okay. Not only this project started out looking at Squeak, Pharaoh, Gemstone, Monticello-based systems. We need some more capabilities. All right. We need better version control. Okay. But I think this piece here makes this a much more interesting proposition. So let's see what we do next here. All right. So how come we don't all use NV, Store, Monticello? All right. It's been a long time, and we're not. Okay. So I think there must be some good reasons for that. All right. And it's a high barrier. Okay, to do that. Okay. Not only are there proprietary storage formats that you have to monkey with. All right. But there's a high cost of porting, integrating into the disparate tool sets. All right. And there's incomplete solutions. All right. I will say I've never used Store and I've never used Envy, so if I say anything that sounds like I'm disparaging these, it just sounds that way. But Git has some features that are fun, that are not found in any of the Smalltalk source code management systems. And that's what's interesting about Git. The project I mentioned that Otto had worked on was called FileTree. It's up on GitHub. By the way, I've been working in GitHub for doing development in Pharaoh right now since January, doing the FileTree project and all the Metacello development. And I've been doing that, and it works. So it's a very functional system. The basic idea behind FileTree is that there's a disk-based package structure that you write to disk that contains the class and method source for a snapshot. Okay, and this is actually concepts from Monticello. All right, so it's not like these things came from out of nowhere, but basically mapping an MCZ file to a directory is the trick. So that was originally developed by Otto. The implementation based on Monticello, so within the Squeak environment, what happens is we have a Git repository that looks like an MCZ repository, a directory repository with MCZs in it, all right, or an HTTP repository. You can copy that Monticello file around, load it, save it, do all the operations from within the Squeak environment, but you're doing it to Git. And really, this is not, really this isn't a lot of rocket science. And that was done basically to make it easy to integrate this. The disk structure itself does not rely on anything. It has no Monticello artifacts, or rely on any Monticello artifacts. And basically, the trick is to use the package snapshot model to solve that naive filing problem, all right? Which is why Smalltalkers have never adopted a file-based system. And what that is I have a system that I loaded a .st file 3 weeks ago. I pulled the new version of the .st file up and I loaded it into the image. Now we all know that doesn't work, all right? Any methods that were removed don't get removed from my image, all right? Things that were added do, things that changed do, but the removals are lost, okay? And then when I filed that thing back out, I'm now adding back in all the things that I didn't remove, and it doesn't work. So in the very beginning we use change sets, all right? Change sets don't scale, but I'll tell you right now that most likely, I know Monticello uses this snapshot model, most likely Envy and Store have something similar. The idea of a package, I'll get into that on the next slide. And finally, the file tree package structure is SCM neutral, okay? So this isn't anything that says, oh, I'm using Git, I'm storing into Git, it's writing to a directory structure. So it can be used with SVN, Mercurial, Git. We can start having that wonderful argument that all other languages can have. What's better, SVN or Mercurial? No, we just can't participate in that at all. And it'll be fun when we get there. Okay, so to get just a little bit more detail about what goes on in the package and snapshot, the package, all right, is an object or an algorithm that defines the contents of a snapshot. And then a snapshot is the state of a package at a point in time. So a snapshot is represented in an image as a collection of class and method definitions. All right, I put that in quotes because in Monticello, we really have method definition, class definition, and a snapshot is an ordered collection of these things, all right? But it's the notion of a definition, because there's nothing special about a Monticello definition at that level. Class, what instance variables, class variables, et cetera, what's the method source, what's the selector, what classes it want to, all of the standard things. So that's the image representation of a snapshot. And then a snapshot on disk is just class and method chunks in a collection of files sprinkled around on disk. So what goes on here is not the content of the package structure or the directory structure. It's the fact that you're interpreting that information as a package, as a snapshot for a package. All right? So I'll try to get a picture here to see if this clears things up. So the file tree package structure starts with, I got a package definition that says the sample class is defined in this package, the sample offer method is in this package, and array is sample is an extension method. All right? That's the contents of the package. I write that out. Okay, sample.class is the directory that holds all the sample class stuff. Sample.st, author.st is sample.st. I have these extensions, classes, snapshot. Some of the structure here at this point in time is intended to allow humans to understand what the heck's going on there, all right? The version of the package structure that Otto had kind of collapsed the hierarchy a little bit. So if you found yourself looking at a method, you didn't know whether it was an extension method or part of a class that was a member of the package. So, and is it how important is it to look at the stuff on disk? If it's on disk, people will look at it. If it's on disk, you will look at it. You will monkey with it occasionally, and you'll want to know what's going on. At least that's the theory. So, but the bottom line is the structure on disk is not important. It's the content. So this could all be one file, one .st file, one .giant file. So the approach that I've gone with now, and this is based on Otto's experience, is a single method per file, all right, is handled very nicely by Git, okay? Git can give you, over time, the history of that particular method. All right, you can sit down and do commit history on that method, and you find out every single change that was made to that method. Something that Smalltalkers we like that's the information we want to have. So, so that's really this doesn't make the Emacs guys happy. All right, throwing a bunch of .st files out there for every method, the Emacs guys go, ugh. All right, so version control, package structure, code formatting algorithms or code formatting style. All right, we will never agree. All right, and like I said, semantically, I don't care. All right. This could all be a binary file, and it is in Monticello. But Git doesn't do a good job on binary files. It's useless, all right? And what we're trying to do is actually enhance the version control experience for the Monticello users and nobody else, all right? And for that we need source, so that Git can do its job. Let's see what we got here. Okay, loading, all right? So this is where the naive filing problem gets solved, okay? Because what happens is, what's stored in the package directory is a snapshot, a version of a snapshot, right? And what happens is you load the snapshot into your image, but you don't file in the code and load the classes, you create definitions. So you have a list of definitions in your version snapshot that came from disk. You create an image snapshot, which is another collection of definitions that was based on applying what's the definition of the package against the image, all right? So now you've got a consistent view of what the version was, what you have now. Compare the two snapshots, you generate a patch. What was added, what was changed, what was removed, okay? Apply the patch to the image, bang, go off to the races. Now, one of the things this does is this is what Monticello does, is it only needs to apply the things that changed. So if nothing changed, nothing happens. The patch is empty and no changes. All right. So nice things that you get using this algorithm. But this is the trick. This is Monticello's trick. This is what was done in 2003, Avi and Colin, and just changing the format, from an NCZ file to something on disk, and now we can store that in Git instead of having to have 100,000 NCZ files sitting in a directory somewhere up on the web that we scan through looking for. Where's version 678 again? So, anyway, where does this take us? All right, status. All right, so basically file tree, obviously, in January, Otto had been using this for 3 months in his production system. All right. I took it and looked at it. Like I said, I played with it, and I went to the Intel mailing list and said, hey, I'm going to do Git, guys. And I'm going to build some package structure. Let's get some feedback, find out what people think, talk around. So basically, within that community, kind of came up with, what we're going to do. And I just stopped my foot. So let's do this, and we'll go forward. And by the way, I said it's like style, all right. And so everybody likes to have their own style. So I added to the file tree stuff that I started with some properties, all right? So there's a property inside each package that says, what format am I? Am I file per method? Am I one giant file? Am I some other scheme? So that basically each package could be filed out, in a different format for a different purpose, all right? My conception is that different groups that are, owning the project that they're using are going to have different needs from different desires. Are they going to want files that they edit in BI? And that's what they want to do. But, or maybe files are a little more efficient to load and they don't care about method level stuff. So again, the format is less important than the content, all right? Let's see, so multiple files, let's see. So I'm believing that we'll be porting file trees to other dialects besides the Monticello-based Smalltalks, all right? And this is trivial, all right? Literally trivial. In fact, I think, Travis, I'm not saying that Travis is trivial, but he does have implementation in Visual Works for a Visual Works package that writes out the package structure to disk, stores that in Git, and does a Git commit actually, and then reads it back and loads it into Visual Works. All right. So I don't know. You've got some interesting things that I'm hoping you put up on GitHub so that you can use for other places. want to use chunk format, and we use the standard Smalltalk 80, class creation, which is the primary area that you run into the issue. So that's not going to cut it for visual works. That's not going to cut it for Gemstone for all of the things that Gemstone does. So, those things need to be monkeyed with, all right? And exactly how, But the thing is the implementation is dead simple, all right? Dealing with these kinds of issues, this is what's going to take all the time, all right? If we spend the time. But, anyway, let's see. And then he's been using it for production, and I have too, so let's go on. So right now, I got to the point maybe about 2 weeks ago where I said, hey, I can actually think about phases of this project now. Things are working, now what am I going to do next, and where are things going? So basically, as I focus on right now, the file tree format is stabilized, all right? It's good enough. There's 11 bugs, 13 bugs, something like that, but nothing critical. The Metacello scripting API. So this is the other piece, all right? Is that Metacello users in the Monticello universe need to have an easy way of integrating the GitHub style or Git repositories into the development environment. Because when you're doing development with a file-based system, you got this directory on disk that holds all the stuff. It doesn't change easily. Like if you're talking to a database, you can say, "Oh, give me the source for that. Give me the source for that. Give me the source for that." But you got a disk, a location on disk where you've got pending changes. That's where maybe some of your file.work is. Maybe you have 2 or 3 images that you want to point to the same spot. So all of a sudden we get into this universe where the development environment you need to tell the development environment which directory you want to use, which file tree repository do you want to use for a particular project. So that's the Metacello scripting API. I think there's 8 commands sometimes. I mean, there's not a whole lot. You fetch, you load, you you can get it, you can register. So the idea of register is you say, use that location. If anybody asks to load this project, go use this location on disk rather than whatever spot they might specify. And this, by the way, happens to map roughly to what the Ruby guys do with their Ruby gems and when they're dealing with GitHub and doing their development. Because they have things, what is it called? It's called Ruby gems and Bundler. And Ruby gems and Bundler does, more equivalent to what Metacello does within the Sweet Gemstone parallel environment. So it does loads, it arrays, it checks what versions are loaded, am I do you have some conflicts there? It goes find things for you on the web and brings them in so you can load them, so you don't have to go do that on manually. Anyway, that's done by Metacello, and then I need to add basically GitHub to that list. Now phase 2 is actually where let's start using this, all right? There's several people that I think are interested where let's have the friends and family, come on over and go down to the basement and see if we can live in it for a while, and basically find out, mainly to develop some guidelines, all right? Because I don't know, how many of you know Git intimately? Okay, a couple of you. So the rest of you are going to go, what do I do? What's Git? Where do I read? What do I read? Tell me just, give me the 5 steps, all right? And what are those 5 steps? And I'll tell you right now, I was where you guys that don't know anything about Git were on January 29th, okay? Google is your friend, all right? And what is it, Stack Overflow is your friend. So it can help you learn these things. And there is a book on GitHub that you want to read. That's the thing to read if you want to learn this stuff. But to do it manually. And the thing is what goes on here is Git is like Smalltalk. You can do a lot of things with it. So you can't sit down in one paragraph and say, oh, this is all you need to know about Git. Because there's branches, there are remote repositories, there are, I'll get into that, I think, coming up here, so I can get into this a little bit more, get ahead of myself, just get lost. So anyway, I'm going to do the porting in phase 2 as well. If there's any, I'm going to report, I think we'll report to Amber, is one of the first places we'll go, because we can figure that out. And I think I'll mention the other thing one of the interesting things with GitHub is you can have a wiki on GitHub, and they have project pages on GitHub that are actually hosted there. All right. So I think for all small talkers, they ought to use Amber to host, to basically generate their hosted pages. All right. And one of the neat things that we're thinking about doing with Amber is Amber is Smalltalk in a browser, and it has a class browser that comes up in your browser. Well, imagine that you go to your GitHub project, you bring up the browser, and then you start browsing the code from the repository, all right, using it, all right? So anyway, and this is all running on GitHub, which is Ruby or something like that, you know. So, you know, we're running Smalltalk in Ruby, no, but basically that, you know, those kinds of things I think are, you know, just interesting and add, you know, basically add value for us, you know, that are using and get familiar tools. So, okay, like most of you don't know what Git is. You know, I think you have ideas. So, but Git is a disk-based, distributed version control system for source code, okay? And each Git repository, or each instance of a Git repository, is a complete copy repository, all right? So that's the distributed part of distributed version control, all right? So you can clone a repository from GitHub to your local disk, and now it's on your disk, and you work on that, and no network activity, nothing, all right? You know, do that for the 5 projects you're working with. They're all local to your disk. You make modifications there. You can commit to the repository, and those are local commits. And when you are comfortable and with what you have, you can push it back up to the, you know, to actually to the remote repository. It doesn't have to be GitHub. It could be another, you know, it could be another disk-based repository that you got for your general stuff. So that's a really nice thing to have. You know, put that on your laptop, sit on the plane. You can work all you want, commit, compare, you know, whatever, and you're off to the races. So this is a clone of a repository basically doing a copy, and you can merge changes from any other clone, all right? So there's a, you know, it's got the history, and it does a very good job of doing history. In fact, Git is object-oriented. It's got an object model underneath the covers. Every single object has a unique ID, and they use that, all right? So they're more like Gemstone. They have a loop table for looking at files and stuff like that. But basically, it's a you know, branching. I think I mentioned that a little bit. Branches are first-class objects in Git. So there's no convention, there's no naming convention, and the first classness about it is each commit has its ancestors, all right? And what happens with Git is it says, if you're not the head of any one branch, all right, then you can't commit because you're not the head. So it enforces commits on the head of a branch, all right? And everything is a branch. You have a master branch by default. If you want to commit, you know, and then you just create a branch, and then you put your commit in there, and then you got a new head, and you're off to the races. So, you know, basically this gives you the ability to just go, I got to run an experiment right now. You know, my local repository branch, commit, do the work, back out, switch to a different version, and you're off to the races. So, this is the most popular. This is the thing that makes me kind of drool about Git. All right. Is the ability to branch, okay? Because all the other stuff is kind of hokum, all right? The branching, that's powerful stuff. And then, you know, being able to clone and stuff as well. It was designed for performance, all right? So this is, when it's Torvalds, all right? You know, he didn't want it to go slow, he wanted it to go fast, and he didn't, you know, milliseconds mattered to him when he was doing a checkout. So the stuff, and part of the reason it gets cloned locally, I think, is for speed. Avoid the network transfer altogether. And when you do push things across the network, you don't push the changes across the network. So it is very, very, very efficient. And then, of course, there is free repository hosting for your repositories, and that's at GitHub. All right, I mentioned that, and I'll talk a little bit more here. So GitHub is at http://github.com. It has wiki, blog, and issue tracking for each project. Code review, integration support. What goes on there is you can do diffs on the web page for your project and look at this between any commits in your repository. A pull request, you're allowed to fork other people's repositories, modify if you're using Git, and then make changes, fix a bug, and push that, or actually put a pull request where the owner of the repository, the original owner, can pull that change back into his repository, merge it there. So this is where the collaboration power comes in, all right? I sit down and I say, I'm going to take Seaside, I'm going to pour the gemstone, all right? So I just suck it over, create the gemstone branch, I start working, you know, sucking things in, something breaks, I fix it for gemstone, and I commit it on the gemstone branch. I work along, and then I discover that I found a bug in Seaside. Well, I take that commit, put it on a separate branch, actually, put it on a separate branch, send a pull request back to the Seaside master repository, they can pull that commit, merge that change, because they know what, you know exactly what the change is back into Seaside, and they get the benefit of the bug fix from you. And it's not something where you had to send an email, pound on the door, you know, because you got the code in your own repository that is working the way you want it. It's up to somebody else to decide to pick it up. So we've got branch visualization, which is useful, source code comparison, and there are over 1 million GitHub users that happened a couple months ago, I think. So there's a lot of developers up there. I think 20% of the projects are JavaScript. JavaScript's the #1 language on GitHub. Smalltalk is number 41. It was 42 a while back. So we added some projects. So,
#1.
Yeah.
#1.
Well, and Puppet is it's in front of us. At number 40. Okay, so why aren't we using GitHub now? Damn it, what? Guys, why are we using it now? Okay, all right. You know, it's relatively new, all right? Well, and so that's the 90s, right? Okay? I don't know the exact dates on that. That had to happen in the 90s or maybe in the late 80s, at least for Indy. Monticello's 2003, okay? Git, 2005, all right? GitHub, 2008, all right? Mantello, 2009. So basically, this is relatively recent technology, okay? And so in the 90s, all right, NVIDIA Store, that technology, that's superior to anything that was out there. All right, we had the best stuff going, and it was Smalltalk, and it was for Smalltalk. All right, but that's no longer the case. Okay, you know, GitHub, I think they leapfrogged in terms of capabilities. I think the branches, the distributed repository, this is good stuff. All right, this is powerful stuff. You look, 1 million users. All right, sharing projects and code up there. All right, these guys aren't just 1 million guys sitting there, just looking at themselves. They're a lot of interactivities going on. Okay, let's see. So, why am I pushing Git? All right, I was sitting down going, I'm going to step on so many toes. I'm just going to answer all the questions that I anticipated, and I have room for more questions than I did hit. There's a compelling feature set for Git. I think I covered that. GST, Redline, and Amber, those are projects on Git. So I sat down and said, don't think too hard, and I had to pick something. So, as I said before, the file tree format, the format that I'm saying we should use for sharing code amongst ourselves, all right, amongst dialects, okay? Because that's the thing is I want to make it possible for us to share code between dialects and have a good versioning model so that we can have the feedback loop, because that's what's missing between everybody pushing .st files around, all right? Or loading Monticello files but not being able to push them back, because frankly, Monticello's, it isn't what we need. So, so that's why I'm pushing it. It's there, all right? Is it the best? I don't care. At this point, there's a lot of good, compelling features. Like I said, let's have the arguments. Let's have. Oh, look, we're over here. We're doing something even more neat, better, more powerful. Excellent. We're file-based now. Oops. Oh, we're off. No big deal. So I'm happy with Monticello. Why should I use Git? So Monticello specifically does have some issues. Like I said, Git does provide superior functionality compared to a Monticello-based system. All right. Monticello versions a single file. All right. 1983 RCS version a single file. That's basic. That's a package. It's a single package. You're correct. Yeah, into a file. But it's a single version, of the package in that MCZ file. And so that means that, if you have a multi-MCZ file project, each one of those guys is wiggling, 1985, CBS was invented because RCS had individual files that were having their version wiggle all over the place. So they invented CBS to wrap around and go, a version of this is this version of that guy, this version of this guy, this version of that guy, this version of this guy. You wonder what that fellow is? CBS for Monticello. I create a version that says use this version of that guy, this version of this guy, this version of this guy. Right? I did that for Smalltalk in 1986 using RCS. And these CBS I didn't know about, so I invented BCS and did very similar things. So the other thing about Git, all right, is it is a directory structure that is saved, not just a single file, all right? Or not just a single directory. So you can have lots of stuff in your Git repository, all versioned together. So one of my bugaboos that you know, I was going to solve the code, but I get, it probably fixes that, is documentation in a version, all right? When you're modifying code and creating a bug fix or whatever, the documentation should be updated, just like everything else, all right? Well, where do I go for documentation? Well, you go to the codegoogle.com for Metacello. Well, that wiki page hasn't been updated for a while. Is that correct? If you have the code versioned with your software, I mean the documentation versioned with the software, then it's your own dang fault if you didn't update the documentation. Because where should the users be looking for documentation? In the project directory, right next to your source code, your repository file. Here's my readme, here's my, you can do fairly well. Here's my Amber code that when you run it in Amber will show you the documentation, right? Okay. And let's see, all right, yeah, and Git branching. There's no such thing as branching in Monticello. There's a branching naming convention, but it's not modified, it's not maintained by the system. Metacello has no branching, nothing. So, doing, significant, groups of people trying to interact at a high rate of speed fails in Monticello, not in Git. So, and that's the kind of stuff you want in the community when you're sharing code. You want to be able to say, I want to be independent of you, who's done a great thing, but you've gone on vacation, I've got a bug fix, I'm going to fix it, continue on, leave you a note, pull this when you get back. I've got my own copy, I can keep running. And the API, you'll be able to mix and match GitHub-based projects and traditional. So for the Monticello folks, basically Metacello will just run the same. There's just an additional specification for how you talk to a GitHub repository. All right. They keep saying GitHub repository instead of Git. We can talk in detail about why I have that little quirk in my language for this. Okay, so I'm happy with store envy. Why should I use Git? Don't. All right? Your entire system is wrapped around store or envy. Continue using store envy. All right? If you've got the bandwidth to switch and you think it will do better for you, well then switch. But don't switch. But if you've got code to share, all right, use this. Let's use Git. Let's use GitHub. Let's use Git. Because all you need to do for that is import and export packages from your development environment. All right. And I think most of the development environments, dialects, have a notion of a package. Okay. That and imagining can be a common definition for that package. All right. To give you a little thing about Monticello, there is a package object in an MCZ file. And you can do real crazy, fancy descriptions there. So do that, but that's what that comes down to. We have to do something like that. It can be done, and Monticello has that technology for doing it. But anyway, you only need to import and export packages. So the idea, you work in store, whatever, you go crazy, all right? You sit down and you go, all right, I'm ready to ship a new version out, all right? Write the package out to Git, push it to the repository, everybody has it. Some guy in Timbuktu finds a bug, you get a pull request, you bring it back down, you import it, put it in your store, whoop, off you go to the races, all right? Those are extra steps that you do, but for the things you're sharing, this is not your primary job. Your primary job is where all your tools are aimed at, all right? So let's not try to take, and aim at something different, but for sharing code amongst dialects, which we don't do, we could do that, and it's not a big cost. Okay, so I'm excited. I didn't put an exclamation there in case you weren't sure. All right. So I'm really excited about Git and GitHub for Monticello-based guys. All right, because the last year I've been sweating this. All right, it's bugging me. I'm happy I don't have to write a bunch of code to make that happen. All right, I was going, I'm going to put branches in that development. It was just the file tree repositories make it trivial to migrate MCZ projects around. So the scripting API will just basically, it was in the works before I saw the light of Git. So that part just went, oh, this will fit very nicely. Oh, nice. Well, synergy. I'm also excited that GitHub could finally make it possible for us to go between dialogues and collaborate on stuff, all right? Way too many, is it decades? When's the last time that we really had a collaboration across Smalltalk dialects? The folks that use Gemstone and VisualWorks and Gemkit, well, that doesn't count, all right? As a community, we're too small, okay? We can't afford to be these isolated guys who sit down and reinvent the wheel or see something cool over there on the other side of the pond and go, oh, this Steve file, so terrible. I'm at the point where I feel that way about an MCZ file, all right? I want to see get up and just go in and have to deal with that again. It's not a horrible thing. I think I threw out the slides, last night, when I rewrote this whole thing. So, but I threw out the slide. Give me, Monticello, all right? I bashed it here, all right? But you know what? It fueled. I really believe it fueled, the sweet and farrow blossoming, all right? That was Monticello, okay? That made it possible, all right? Made that community able to share code at a much more efficient rate than they'd ever been able to do before. So I really believe that, all right? So I'm not, oh, Monticello, worst thing, get out of here, it's just, it went so far. 2003, there are better things around. Let's take advantage of it. So, so we have to combine our resources. We have to collaborate. We have to, all right? So, I think that's it. So questions, wait. I might have a tear here. I have a impassioned plea, I think. Let me look and see if I can. Oh, all right, I want to do a slide, but I ran out of time to put on. The onus is on us. All right. Okay, I want to my brother. Let's see. Oh, no, yeah, I think I said all these things earlier in the thing. But, it's like it's a crime if we don't do it. It's too easy, all right? Right, Travis? It's a crime, okay? And like I said, this doesn't replace, don't throw the thing out. It's auxiliary. Okay, questions? Yes?
Dale, I think this sounds really fantastic, and I'm really excited about your excitement. It made me excited, and I agree with everything you've said here in terms of what we need to be doing, and the way you presented it. It sounds like it provides that facility to do that, in particular the collaboration aspect, polling. I really like that. But the thing you knew there was a bug. You said it does resources, but you also said that it only supports text.
Oh, no.
Oh, you can't do binary?
You can put binary. So if you put binary, it's binary blob. So if you're expecting to do this on the binary blob.
But I could have versions of binary. So
absolutely. Files.
Now I'm really excited.
Change files.
Because when you said documentation and it's in your slide you had HTML, CSS, and I was thinking pure text. I said I want to store objects.
Oh, yeah.
I've got my object model that I want to have, which is required.
Your test object model is part of what you want to have happen or whatever. Yes, binary files and handles it. All right. The thing is with if you're doing source and wanting to collaborate with source, you need the source, but everything else is all.
One more quick question: do you think there'll be any performance issues having one file per method?
It could be. This is one of those where we'll cross that bridge when we get to it.
Thanks.
It's like
So I was just going to make a comment, but it's actually very timely considering Chris's question. When I did this, I did it on method per file as well, and that was the big concern I had and was warned about is, you do that, you're going to have, these tools just aren't designed to deal with thousands of files. And I was kind of blown away by how incredibly efficient Git is. I took bottom feeder, which is kind of my random test application for lots of stuff. It ends up with by the time you get all the packages, something like 7,000 files by the time it expresses all the methods. So one area where it's never going to be efficient in this is it does use a lot of disk because your minimum block size per file. But disk is cheap. I'm a long way from it. So what blew me away was how fast I could move this to and from GitHub. I could instantiate all of those 7,000 files in about 3 seconds. I was blown away by Mac OS X, Git, whatever it is, whoever's screaming. I was like, I didn't know you could make files that fast, much less MEM. It was amazing how fast it was.
Yeah.
And then when it does the differencing, this is where you play a balancing game between your resolution of files because the tighter you cut the files, the more it can do with differencing them and limit how much it sends back and forth. Whereas you start using big binary files, it starts having to send big binary diffs to get that to you. So
Yeah.
that was, I guess, the experience I'll add to my outside
Yeah, yeah.
is it can be made to go fast. The biggest problem you have, probably performance-wise, is parsing the files up into Smalltalk.
Yeah, that's
On my
what
side,
we're-
I played some games to make that go pretty quick and
Yeah.
make it update pretty fast.